Alrighty, so as we can see here, we're going to be testing for symmetry with respect to an axis. So let's just take a look at this little diagram right here. So here we have this sketch right here, and we can see that this the two graphs right here, the blue and the red, is being cut in half by the y-axis, right? And so that means that if you were to fold the red onto the blue or the blue onto the red, that it would match exactly. And so we would say that this graph is symmetric with respect to the y-axis, right? And this is a very nice visual representation. So if you have a graph, you can tell very easily by looking at it if it is symmetrical with respect to the y-axis. Same thing right here. We can tell that these two graphs are being cut in half nicely by the x-axis, and so that we would say that this is symmetric with respect to the x-axis. So that's what we're going to do here. We have these two graphs right here, and we want to know, is this right here reflected across the x-axis, or not? Actually, not reflected, but is it symmetric with respect to the x-axis or y-axis? So let's first do this visually, and then we can do it algebraically. And I'm going to be using a really cool and awesome tool called Desmos. And I invite you to use Desmos all day, every day. It's pretty rad here. So I'm going to go ahead and graph the two functions that are actually, we'll start with the first one. So that's x equals y squared plus 1. So let's just go ahead and do that. X equals y squared plus 1. Right, so I mean, as you can see here, this is actually very similar to what we just saw right here, right? But even if we didn't see that, we can see here clearly that, you know, if you look at this point right here, like 2, 1, then this is going to be 2, 2, negative 1, right? So sometimes it's kind of hard to get that right on there. But see, if the point here is xy, then it's reflected across the x-axis is x negative y. So the x stays the same and the y changes. So we can see here that this one right here is going to be with respect to the x-axis. And so let's kind of write that in right here, the x-axis. Right? And then what about this guy? If you actually know what this one right looks like, it's a circle. Right, and we know that with any circle we can kind of see what respect is going to be cut into. But we'll just go ahead and do that guy. Right, so I'll just leave that guy there, turn it off, and x squared plus y squared, and that's going to be equal to 4, I believe, right? Yeah, great. So here, this is actually going to be reflected, or not reflected, I keep saying that, it's going to be symmetrical with respect to the x and the y-axis, right? I mean, you can cut it down vertically or horizontally, and we're obviously going to get the same graph twice there. So here, we already know that the answer is going to be the x and the y-axis. All right, but say if you had some kind of assessment and you couldn't use a cool tool like Desmos. I'm not sure why they wouldn't let you, but you know how some teachers can kind of get kind of crazy on that kind of stuff. So how do we figure this out without a cool tool like Desmos or your graphing calculator? So here's basically the two rules here. All right, the graph of a relation is symmetric with respects to the y-axis if the replacement of x with negative x results in an equivalent equation. Meaning I'm going to replace x with negative x. And if I get the exact same equation, then it must be symmetrical with respect to the y-axis. And that should make sense visually. Look, if I plug in an x value or even a negative x value, notice that we're going to get the exact same y value. Right, so you can see that visually. So watch this. So that means that this should happen then. Well, that will happen for the second one because that is with respect to the y-axis. And then lastly over here, if something is symmetrical with respect to the x-axis, then you plug in negative y in for y, and that should give you an equivalent equation. So let's go ahead and just start here, and let's just replace x with negative x. Like, let's just say like we didn't know which one it is, right? So negative x equals y squared plus 1. And so if I want to get rid of that negative, and we'll just get 1 minus y squared. Now, is this equivalent to this equation right here? Or this, this equation? Are these equivalent? Well, no, right? They're not the same. But if I do this, x equals negative y squared plus 1, and I get x equals y squared plus 1, because when I square negative y, that's negative y times negative y, which is just y squared. Now this is equivalent to that guy, right? So because I replaced y with negative y, that means that this is symmetrical with the x-axis. And we found that to be true when we used Desmos right here, right? I mean, we can see that in the graph that this is being cut in half by the x-axis. So that means it's symmetrical to the x-axis there. So in the same way, right, I'm not going to now do the work here, but you can see if I plug in a negative x, that just becomes a positive x squared, and now it's the exact same thing. Or if I plug in a negative y, that just becomes a positive y squared, and then we get the exact same thing. Hence, this is symmetrical with the x and y axis.